on this exam. Okay, this was a good one. It was very good one to have as a question right before your exam. Basically, most lottery games USA allow winners of the jackpot to choose between two forms of prize: annual payments or the cash value option. In the case of the New York Lotto, there are 26 annual repayments. The first payment immediately and the last payment in 25 years' time. That indicates that they're yearly payments, not monthly. Okay. Second thing, the payments increase by 4% per year. The amount advertised as the jackpot prize is the total amount of these 26 payments. The cash value option pays a smaller amount than this. If the amount of the first annual payment is A, why is it A? Because you get it immediately. Okay, immediately is A. Okay, now if you get A in 1 year's time, it increases by 4%. So it's A multiplied by 1.04 because it undergoes a 4% increase. Okay, next one, 2 years worth of 4% increases. One after that, 1.04 to the power 3, and then finally A times 1.04. Remember, the second payment is the power 1, third payment is the payment 2, 26 payment, power 25. Is that alright?
Yeah.
Now, the 26 payments form a geometric series. Use this fact to express the advertised jackpot in terms of A. Now, geometric series, Sn equals, what do we always do with you guys? The 1 minus Rn version, isn't it? 1 minus Rn. Yeah, that's the only one we use, okay? Now, our A value, our first payment is A, so A equals capital A. Our R value equals 1.04. So it's going to be A into 1 times 1.04. Oh, sorry, my fault. Yeah, I'm on it. Sorry. 1 minus 1.04 to the power of 26. Oh, yes. Sorry. Yeah. All over 1 minus 1.04. Now, you haven't made a mistake here, but what you're gonna, it says use the express it in terms of A. You'd be expected to simplify that down, and you're expected to put the answer beside A. So the answer is, and whatever you do, guys, because you're talking about big time money here, you got to keep a lot of decimals. Because if you chop that off, when you chop off 100 or 1,000, you're talking millions of euro. That's a significant amount of money. So the bigger the amount of money, the more decimals you have to use. So we're going to just use a couple of decimals here. 3, 117. Now you might not use this many, but
so where did you get this from?
what? Oh, sorry. If you want to get that number there, what you do is you just say, I'm just going to do it bit by bit. 1 minus 1.04 to the power 26.
Oh, sorry, now.
It's okay. We're just going to do that part first. Then we're going to divide that by 1 minus 1.04. And that's that number there. Okay. Now that that's done, what we're going to do next is part C. Find correct to the nearest dollar the value of A that corresponds to an advertised jackpot of 21.5 million. Your 21.5 million equals your 443,117,4462A. You just store that in the calculator. You're going to divide your 21.5 by that. Now, because I already have it in my calculator as answer, now it's going to be 21.5. Oh, wait a second. 21 million, isn't it? So 21 and 6 zeros, yeah? Five zeros. 1, 2, 3.
It's 21, 5, and then 5 zeros.
Yeah, sorry. There we go. There's our 21 million and 500,000. We'll divide that by our last answer, and that will give us an annual repayment of 485,198.68. Now, whether you got full marks or not is sort of like a rough estimate of how far you're out. Like you're about €1 or €2 grand, but about 10, 20, 30 quid. It's too much. It means you didn't give me enough decimal places. Okay? So I don't know what the tolerance would be in the exam, but I just decided to go strict on you, just so you won't make that same mistake again.
Was it 5 marks out of that?
Yeah, be 4 or 5.
Because
You lose
you
one
know
of
I
those.
didn't get the answer from the part B, or did it? Didn't Wayne
So what we have next is the winner who chooses the cash value option receives immediately the total of the present value of the 26 payments. The interest rate used for the present value calculation is 4.78%. We want to find the cash value of the price referred to in part C. Complete the table below and show the actual amount and present value of each of these first annual repayments. Okay. Now, the first one, you get it today, and it's worth this much, which means its present value is still worth the same because it hasn't accumulated value, or because it isn't old. You're giving it today. Okay. Now the second one, however, is 1 year's time, and we know to get the 1 year's time we have to multiply our 485,199. We got to multiply that by 1.04, and I'm going to make this series now. Multiply by 1.04 every time. 504,606.96 multiplied by another 1.04. I'm basically doing the series from part A, haven't I? So multiply by another 1.04, you get 524, 791.24. Okay. Now, let's revert back to present value. You're told that your growth rate is 4.78%. That means every year you're going to multiply a sum of money by 1.0478. You're going to multiply that. If it's there for a year, you multiply your sum of money by that, and you get the value of it in 1 year's time. However, we're going to receive this in 1 year's time. We want its value today, which is the reverse process. You divide it by 1.0478. Because if you receive that in 1 year's time, you got to take away the growth factor to find its current value today. So divide by that, and what you're getting is 587.10. Same deal again. This one here, guys, everybody see it? This one here is given to you in 2 years' time, which means it needs to be divided by the growth factor to the power of 2, because it has 2 years to accumulate interest, so its present value would not be that. So what we get there is 478,002.02. Now, what we're trying to ask you guys is, how do you go from this value here to this value here, from this value here to this value here? There's a sequence involved here. The sequence is like this: 581,199. You remember we first multiply it by 1.04. That turns it into this part here. And then we divide it by 1.048. Okay? And then that sends it back to this value here. So this is a geometric series where you multiply by 1.04, then you divide it by 1.0478, and how many times you do that depends on how many years in the future it happens. Example for the second one, which is here, you multiply that one by 1.04 squared because you're given it 2 years in the future, according to part A of the question, and then it's in 2 years' time. Therefore, you then have to divide it by 1.0478 squared to determine its current value. That makes sense? So therefore, there's a generic formula. I just did it there, didn't I? It's your 485,199 multiplied by 1.04 to the power of n. 1.04 divided by 1.0478 to the power of n. It's unlike any question you've done before. It just had a curveball in it. Okay? Connor.
Would it be correct also?
Connor asked me, would this answer also be acceptable? Which it is. You know by the marks it is. It's going to be 1.04 to the power of n, 1.0478 to the power of n. Any reason why you know that's acceptable? If I say 2 over 3 to the power of 2, the answer is 5 over 9, alright? Reason being, it's 2 squared over 3 squared. In the same way, if I change the 2 to an n, if I change the 2 as a power of n, it's going to be 2 to the power of n divided by 3 to the power of n. Okay, so both answers are acceptable. Now, finally, find the amount payable under the cash value option, that is, find the total of the present values of the 26 payments. Okay, so the total of the 26 payments. So look at this, okay? It's the sum of, we'll just do the it's the sum of 26 payments, correct? First payment is our 485,199. Your second payment is this, but then it's to the power of 1.04 over 1.0478 to the power of 1. And then we're going to dot all the way to the future, where it's going to be the same number multiplied by this number here to the power of what, guys? Power 25, okay? So, with that in mind, it's a geometric series, okay? It's a geometric series, so we're just going to put in our Sn formula. Sn equals a into 1 minus Rn all over r to the power of n all over 1 minus r. Is that okay? Now, what we're going to get next is that our a value is our 485,199. Our r value is going to equal b, and b is equal to 1.04 divided by 1.0478. 1.04 divided by 1.0478 gets us that number there, yeah? Shift star as B. Okay, next thing we're going to do is we're going to put in this number our 485, that's a 199 all over 1 minus B. What is B, guys? So what's n? 26 payments, all divided by 1 minus B. You put that in your calculator, we all know how to do that, and your answer will turn out to be roughly 11,500,000. Cool enough with that? Now, our next one is, you get taxed on this. This money just doesn't end up on your lap, you're going to get taxed on it. An Irish woman did this earlier in the year. After tax she received 7.9 million. Okay, what percentage of tax was charged on her winnings? Well, your 11.5, take away your 7.9, get you 3.6. Your 3.6 million over your original 11.5 million multiplied by 100 will tell us the percentage. Your percentage was 31.3%. So, this one here is proof by induction 2 to the power of n is greater than or equal to n squared, where n is n of the n greater than or equal to 4. Now, first of all, prove for p of, anybody? 4. P4 is 2 to the power of 4 greater than or equal to 4 squared. 2 to the power of 4 is 16. 16 is greater than 16. Greater than or equal to 16. True for P of 1. Okay, done. Now I'm going to...
Do you still say P of 1 even though it's P of 4?
Oh, sorry. My fault. True for P of 4, you're dead right. Because I start off with 4. Okay. P, the number refers to what number you replace for n. Okay, so if I said n greater than or equal to 20, I'll start off at P20. Okay, now that's done, guys. What we're going to do next is we're going to go for assume true for P of K. And P of K will get me 2 to the power of K greater than or equal to K squared. Okay, so give me another 5 marks. I'm on 10 out of 20. You should always pass an induction question. Okay, there's just no way of not passing it. Now, next one after that, guys, is prove for P of K plus 1. And p of k plus 1 is going to be 2 to the power k plus 1 greater than or equal to k plus 1 squared. Now, using the rule of indices, we're going to have 2 times 2 to the power k. Everybody understands that's 2 to the power 1 by 2 to the power k, which is 2 to the power k plus 1. It's greater than or equal to k squared plus 2k plus 1. Now, the whole point about this is 2 times a number is greater than or equal to this number. If I replace 2 to the power of a k with a smaller number, which is up here, I'm going to replace 2 to the power of k with k squared. Therefore, this number here is bigger than the red number below it. And if I prove that this number is bigger than k squared plus 2k plus 1, I'm in business. Okay? So, what we get next is 2k squared greater than or equal to k squared plus 2k plus 1. K squared cancels with k squared. And then we're going to be left with k squared. I'm going to bring this over to your side. Minus 2k minus 1 greater than or equal to greater than or equal to 0. Yeah. Now, what I'm going to do is I'm going to set up a perfect square. Let me show you what I mean by setting up this perfect square. If I did k squared minus 2k, if that was a plus 1, that'd be amazing. As in, it'd be k minus 1 squared. Have we got that? So what I'm going to do is this, a little trick that you would have seen before. Plus 1, but it has to be minus 1, right? So what I'll do is I'll have a minus 2 at the end. And then I'm going to underline this. This here's a perfect square. K minus 1 squared minus 2 greater than or equal to 0. Now, I have to figure out why this is true. I'm going to show you. True because minimum value of k minus 1 squared is when k equals, what's our smallest value of k? 4. Okay? K minus 1 squared would therefore be equal to 9. Do you understand? 4 minus 1 squared. 9 is bigger than minus 2. Oh yeah. Sorry, I'll bring that 2 back over actually, if you don't mind. I'll bring it over to your side again. And what I'm saying is that the question states that n has to be 4 or above. So what I'm saying is this perfect square here, see the k minus 1 squared, it's going to get bigger every single time I choose a new number. I start off with 4, it's 9. I start off with n equals k equals 5. If then comes 16, it's going to get bigger and bigger and bigger. So what I'm saying is that the minimum value of k minus 1 is when k equals 4. It's still bigger than minus 2. Therefore k minus 1 squared is greater than or equal to 2 for all k greater than or equal to 4. Hence, by the principle of mathematical induction, p of k plus 1 is true if p of k is true. Hence, by principle of mathematical induction, p of n is true. If people are wondering about this k minus 1 squared greater than or equal to 2, think of any number. You can use 4, 5, 6, 7, 8, 9, 10 all the way to a million or a billion. No matter what, you're squaring the number, and when you square that number, it's got to be bigger than 2, because it specifically states that you have to start off at 4. Okay, Whelan. Okay guys, this one's question 8. Now in question 8 we're asked to express this in the form a plus bi. Now, this is how you get marks here. A plus bi. Straight away, square both sides. 5 plus 12i will therefore equal a plus bi multiplied by a plus bi. Now it's just an identity. 5 plus 12i equals a squared, and then it's going to be plus 2abi when you multiply it out, plus b squared I squared. Anybody, what's b squared I squared? Minus b squared, okay. Now this minus b squared, guys, what's going to happen next is we have a real number on the left. The real number is 5. On the right, the real number is... Okay, so a squared minus b squared equals 5 is one equation. 2ab equals 12 is the second equation. Therefore, a will equal, what's it, 12 over 2b, which is 6 over b. Substitute in a squared minus 6 over b squared equals 5. A squared minus 36. Oh, wait. Yeah, sorry, no. One mistake. Substitute in for the wrong one. A is 6 over b. So 6 over b squared minus b squared equals 5. 36 over b squared minus b squared equals 5. Put everything over b squared. B squared over b squared. Another b squared over b squared. Now, what happens here is the b squares in the bottom cancel. You're going to have 36 minus b to the power 4 equals 5b2. Some of you guys are going b to the power 4. We don't do that, right? And you'd be right. So we bring the b4 to the right, minus 5b2 minus 36. And thank you, Whelan. It's quadratic, but you're going to have to make a substitution. Y equals b squared. Therefore, y squared equals b squared 2b squared, also known as b to the power of 4. This equation turns into y squared minus 5y minus 36 equals 0. Y minus 9. Y plus 4 equals 0. Y equals 9.
Good morning, here today's announcement. Indoor rowing.
Here's this. We have y equals 9 or y equals minus 4. We're going to get the a values of both of them, right? So a is equal to, what did we say it was? 12 over 2b.
To be or not to be?
Sorry, we're final announcement for 5th years. Your photograph takes place in the hall.
Okay, ready guys? So 5b squared is b power 4 minus 5b. It's a quick fix. That was a plus 5b, by the way. Remember, I brought the b4 over the other side. It was a plus 5b. Plus 9 minus 4. Okay. So it's minus 9 plus 4. Sorry, minus 9. Oh yeah. That's a minus 4 then, which makes it a plus 4. Sorry about that. Now guys, we found out the a values now. So, oh wait. Sorry, stop. I know what happened. Okay, our substitute in. We substitute y equals b squared. So b squared equals minus 9 or b squared equals 4. We don't do the b squared equals minus 9 because it's another complex number. Can't be done. B therefore equals plus or minus 2. So b equals 2, b equals minus 2. Therefore our a value is 6 divided by b. 6 divided by 2?
3.
6 divided by minus 2? So your two complex numbers are a plus bi. You have a choice. It's either 2 plus 3i or minus 2 minus 3i. That always happens. They're always the plus or minus version of each other in these particular type of questions. Now, alright, we're just going to take the 2 plus 3i back to the top. Now here's how you're going to solve a quadratic equation with coefficients that have I in them. You're going to do the minus b formula, as you always would. Z equals 1. I'm going to multiply that out to get minus 1 minus 4i for b. A equals 1. You looking, guys? B equals minus 1 minus 4i. C equals minus 5 minus I. Now, b squared minus 4ac, minus b plus or minus square root of b squared minus 4ac all over 2a. Put it in. Minus b is going to be 1 plus 4i plus or minus the square root of b squared. Anybody? Might as well do it over here. B squared is 1 minus b squared is 1 minus minus 1 minus 4i into minus 1 minus 4i, which is going to give me 1 plus 8i minus 16i squared, which is going to be 1 minus 16 minus 15, isn't it?
Does I squared not change?
It does, to minus 1. 1 minus 16. So it's minus 15 plus 8i is the b squared part, minus 4 times a times c, which is minus 5 minus I, all over 2 times 1. Stay with me. 1 plus 4i plus or minus the square root of. Now that is going to be minus 15 plus 8i. That's going to be minus 4 times 5 plus 20 plus 4i. Look what happens next. It turns into 5 plus 12i. Always happens that way. It'll always turn into the one we had at the start. And remember what we said earlier? Square root of 5 plus 12i all over 2. We specified that our a plus bi is equal to the square root of 5 plus 12i is 2 plus 3i. So plus 4i plus or minus the square root of 2 plus 3i all over 2. Wrap it up, and what we're going to get is 1 plus 4i plus 2 plus 3i all over 2. And the second answer is 1 plus 4i minus 2 minus 3i all over 2. And after that, we're going to get a very long question. Is what's it? 3 plus 7i over 2, or what's it? Minus 1 plus I over 2. You can break it up into 3 over 2 plus 7i over 2 minus a half plus I over 2.
I don't like that.